Assalamu alaikum. Am I audible?
Salam, sir. Yes, sir.
Okay. So, any doubt related to last class?
No, sir.
We have started this linear expansion due to change in temperature, and which I had derived you this part. Final length at any temperature T or any change in temperature delta T, for which alpha is temperature coefficient of linear expansion and n naught initial length of that particular object. Let me give you a question. The length of a rod at 27 degrees Celsius is 1 meter. Find temperature at which its length becomes 101 centimeter if alpha is 2 into 10 to the power minus 3 Kelvin inverse. Let me give you a hint how to solve. In this part, we have initial temperature, that is T naught, 27 degrees Celsius, at which length of rod is 1 meter, that is L naught. So find temperature at which length becomes 101 centimeter or just 1.01 meter if alpha is this. So use above formula and try to find. You may write alpha equals to delta L divided by L naught times delta T. Move this delta T to left side equals to delta L by L naught times alpha. Delta T is change in temperature, so it will be T final minus T initial equals to delta L, that is change in length, final length minus initial length by initial length times alpha. Put all the values and simplify it. You'll get the value of T. Try to solve. Any problem while solving? Hamza?
Not yet, sir.
Okay. We have to calculate T. So T minus T naught, that is initial temperature, we have 27 degrees Celsius. Final length is 101 centimeter. So in terms of meter, it will be 1.01 minus 1 divided by initial 1. Alpha is 2 into 10 to the power minus 3. So 1.01 minus 1, it will be just 0.01 divided by 2. If we move this 10 to the power minus 3 to numerator, it will become 10 to the power plus 3 or just 1000. So on solving, just move this decimal. So they'll have 100. 20 cancel out. So 10 divided by 2 will be 5. Move this 27 to right side. So T will be equals to 32 degrees Celsius. Hamza, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay. Now related to this expression for linear expansion, we may find some other expression as well. Like, since we have alpha equals to delta L by L naught times delta T. So first is delta L by L naught. So it will be equals to alpha times delta T. This particular quantity, change in length with respect to original length, is also termed as strain, which I had defined you in chapter solid, mechanical properties of solid. And since this particular strain is due to change in temperature, so we can write it as thermal strain. Hiba, is it clear?
Yes, sir.
Now, according to the formula of Young's modulus, we may write Young's modulus equals to stress divided by strain. So stress will be equals to Y times strain, and strain is alpha times delta T. So it will be another formula to calculate thermal stress. Now further, stress equals to force divided by area of cross section. So if you have to calculate force developed due to change in temperature, so it will be area times stress, YA alpha times delta T. So related to this thermal expansion, we may find these three different quantities. Hamza, any doubt?
Sir.
Okay, just write it down.
Done, sir.
Now there will be some theoretical question related to this part. In case of bimetallic strip, suppose two rods of different material. Let's say this is one rod joined side by side to another rod, this. So this may have some alpha 1, alpha 2. I'm considering alpha 1 is greater than alpha 2. What this alpha actually tells us about? It simply defines the rate at which length will increase or decrease related to change in temperature. So greater the value of alpha, there will be more rate of increase in temperature, increase in length as compared to change in temperature. And similarly, on decreasing temperature, it will tend to more contraction in length on decreasing temperature. So you can say alpha proportional to elongation as well as compression, both on increasing temperature and on decreasing temperature. So related to this part, you'll be asked, suppose the system, if temperature is increased and if temperature is decreased, so what will happen to the shape of this bimetallic strip? Will it be remain straight or it will bend? Hamza, any guess?
That will bend.
Okay, so towards which direction it will tend to bend? It depends upon their alpha. Greater the value of alpha, on increasing temperature, it will tend to more elongation. Since in this part, alpha 1 is greater than alpha 2, so blue will increase more. So the shape of this particular bimetallic strip will become like this. It means outer portion is towards convex side, and this is towards concave side. So you'll be asked on increasing temperature, which of these two rods will be towards convex side or concave side. So related to alpha 1 and alpha 2, we may define this particular structure. Similarly, what will happen if you decrease the temperature of system? Which one will be towards concave and which will be towards convex? Hiba?
So the red strip will turn towards convex side.
Good. Since on decreasing temperature, greater the value of alpha, it will leads to more compression in that particular rod as compared to the other part. Since alpha 1 is greater than alpha 2, so blue will get compressed more as compared to red one. So red will be towards convex side and blue one will be towards concave side. Khalid, any doubt?
No, sir.
Okay. Hamza, done?
Yes, sir.
Now, next is pendulum clock. Suppose a clock is designed to operate or to work on oscillation of pendulum. So in this case, if a pendulum oscillates from one end to other end, it takes 1 second. And then on returning back, again, it takes 1 second. So in total, for one complete oscillation, it takes 2 seconds, during which the reading of clock will go from this point to this point, 1 tick, and then 1 tick. That is 2 seconds. Let's say this rod is composed of any metal, so its length may get changed on changing temperature. Initially, at low temperature, or at some temperature for which it is configured to work properly, length of this particular rod will be L0. So what will happen if temperature is increased or temperature get decreased? So on changing temperature, length will change, which leads to change in time period and which further changes the reading of this particular clock. So delta T equals to half alpha T naught times delta T. This is final part you get derived if you solve time period of simple pendulum related to any two different temperature. So let me define you this formula only you have to use. Delta T is change in time by this clock. Alpha is coefficient of linear expansion. T naught is duration for which we are calculating. And delta T is change in temperature. Khalid, any doubt?
No, sir.
Now let me define you what will happen if you increase the temperature of this particular system and decrease the system. First, write it down to this.
Sir, what did you write for delta naught?
Khalid, where is delta naught?
Sorry, the T naught.
T naught is duration for which we are calculating. So duration of calculation. We are calculating for
Okay.
1 day, half day, 5 days, 7 day.
Done, sir.
Done, sir.
Suppose I'm decreasing temperature. If temperature is decreasing, so what will happen to the reading of clock? In this case, on decreasing temperature, according to the formula of simple pendulum, time period equals to 2 pi root under L by G. So on decreasing temperature, length will contract. On contracting length, time period of going from one end to other end will also decrease. since length get decreased. So in this part, we can say on decreasing temperature, length will decrease according to concept of linear expansion. Temperature and length will be proportional to each other, or you can say on increasing temperature, length will increase, and similarly on decreasing temperature, length will decrease. So in this part, length will decrease due to decrease in temperature, which will lead to decrease in its time period. So initially, it was taking for half oscillation from one point to another 1 second. Now it will take, let's say, 0.9 seconds to go from one end to other end. And similarly, on returning back to its own position, again, let's say it takes 0.9 seconds. Khalid, is it clear?
Yes, sir.
Now, in this period, what will be the reading of clock? Clock just read the oscillation part, not the duration for which it is taking place. So for half oscillation, it just read one tick, and for the next half, it just read one tick. So in total, it will read 1 second, 1 second, 2 seconds, but in actual, total duration for this complete oscillation is 1.8 seconds. So will the reading of clock in this case is increasing or decreasing with respect to actual time? Actual time is 1.8 seconds and reading of clock is 2 seconds. So is it increasing or decreasing? Hamza?
The increasing.
Good. So we can say on decreasing temperature, length of pendulum will decrease, oscillation or period of oscillation of pendulum will decrease, hence reading of clock will increase or reading of clock will become fast. Similarly, on increasing temperature of surrounding, length will increase, time period of oscillation will increase, so reading of clock decreases in that case. Khalid, is it clear?
Yes, sir.
Let me define you that part also. Let's say if temperature is increased, so for oscillation of this point to this point, let's say temperature is increased. So this increase in temperature will lead to increase in length. So period of oscillation on going from one point to another will be more than 1 second, let's say 1.1. And then on returning back, it will again take 1.1 second. So in total, it is taking 2.2 seconds. But during this, the reading of clock is 1 tick and second tick, just 2 seconds. So just compare the reading of clock and oscillation time period. Reading of clock is more or less as compared to actual time taken. Hiba? Hamza? Reading of clock is increasing or decreasing in this case?
The increase.
Just compare. 2.2 second is time taken by oscillation of pendulum, and we have to define the reading of clock with respect to oscillation. So will the reading of clock is increasing or decreasing?
The decreasing.
Good. So in conclusion of this whole part, we can say For the first part, on decreasing temperature, length will decrease, time period of oscillation will decrease. So reading of clock becomes fast. In second part, on increasing temperature, length of pendulum will increase, time period of oscillation of pendulum will increase, and hence the reading of clock will decrease or become slow.
Done, sir.
So this is all about linear expansion of rod and its related application. Next is areal expansion, which is also called superficial expansion. Suppose a rectangular block initially length L0 and breadth B0. So on increasing temperature, it will tend to increase along its area like this to reach at this point. So final length will become L and final breadth B. So as like alpha, linear expansion or coefficient of linear expansion, we may define for this part beta, coefficient of areal expansion. So it will be equals to change in area divided by original area times delta T. So unit related to this term will be again Kelvin inverse or Celsius inverse. So related to this expression, you may define this beta as The ratio of fractional change in area to the change in temperature is called beta. It defines at what rate area will increase or decrease with respect to increase or decrease in temperature. So beta is the ratio of fractional change in area to the change in temperature. It defines the rate at which area will change with respect to change in temperature. Hamza, any doubt?
No, sir.
So on rearranging, we may write beta equals to delta A divided by A naught times delta T. Just cross multiply. So delta A becomes B times A naught delta T. Delta A is A minus A naught equals to beta A naught times delta T. Move A naught to right side. So A will be equals to A naught plus beta times A naught delta T. Take out A naught as common. So you're left with 1 plus beta delta T as your final expression for A, which is similar what we have obtained for length in the above part. Hiba, is it clear?
Yes, sir.
Okay. Just write it down. Iba, done?
So the last part.
Okay.
Done, sir.
Salman, any doubt?
No, sir, no doubt.
Okay. Now, first question related to this part will be define a relationship between alpha, that is temperature coefficient of linear expansion, and beta, that is temperature coefficient of areal expansion. So first is the relation between alpha and beta. So how to relate? Let's say as length equals to L naught 1 plus alpha delta t according to linear expansion. Similarly, we may write breadth as length as 1 plus alpha delta t. Since these two are nothing but length in different sense, so on multiplying, you'll get L into B equals to L naught B naught 1 plus alpha delta t and 1 plus alpha delta t. Both having same quantity or having same base, exponential 1, so it will become A naught 1 plus alpha delta t to the power 2. Now using binomial expansion, we can say 1 plus x raised to n will be 1 plus n times of x. So using this part, you can say this 2 exponential will move to its coefficient. So you're left with A naught 1 plus 2 times alpha delta t equals to A as final area. Now just compare this equation and this equation. Let's say this equation is first and this equation is second. So on comparing equation first and second, we have same quantity A in left hand side. We have same term A naught as coefficient of that bracket, and 1 delta t. So on comparing these two equations, you'll get beta equals to 2 times of alpha, or alpha equals to beta by 2. Hamza, is it clear?
Yes, sir.
Okay, just write it down. Hamza, done?
Yes, sir. Done.
Okay. Now, related to this areal expansion, there will be a question like, let's say this is any metallic sheet. This is point A, point B, C, and D. On heating, how will separation between first AD, second BC will affected? Khalid, any guess?
Sir, what was the question again? I got disconnected.
We have metallic sheet, this having two cutout holes, in which for first part at its diametrical end to end point AB, and for second CD. So on increasing temperature or on simply heating, what will happen to its separation between A and D and B and C? Whether it will increase, decrease, or remain same?
Sir, it will increase.
For part, first or second?
The first one.
Okay, and what about second one?
Second will be decreased, I think.
Okay. Hamza? Same answer or different one?
The first will decrease.
Okay, first will decrease. Why first
And
will decrease? Let me ask you the third part also. A to B. Let me give you some hint how to simplify this part. First thing, this whole arrangement will be nothing but arrangement of particle. And if there is hole, so arrangement of particle will be all around its circumference like this. So what will happen on increasing temperature? Will the separation between particle decreases or increases? Hamza?
The increase.
Good. So initially, particles are arranged like this, having very small separation or negligible gap in between them. So on increasing temperature, separation between each particle will increase. So it will tend to acquire this configuration. So if I ask you what would be the separation or what would be effect of separation between A and B, so you'll say initially A and B initially at this point. Now on expanding, it will reach to this and this end. So will the separation between A and B increase or decrease? Increase. Okay. Now, just arrange number of particles between B and C. So initially at low temperature, there will be some number of particles arranged linearly in between B and C like this. So if you increase the temperature, so will the separation between particles for B and C arrangement will increase or decrease?
Increase.
So it will tend to increase. So separation between part B and C will increase or decrease? Increase. Hence, for A and D also, it will increase. For B and C, it will increase. And for A and B, increase. For all situations, separation will increase. Hamza, is it clear?
Yes, sir.
Okay. Similarly, for this question, you will be asked if this cutout portion is placed like this. How will this cutout portion and hole on heating will change its dimension? So you'll say this cutout portion and the arrangement of particle at its circumference of hole are made up of same material. So on heating, both will expand at same rate. Is it clear?
Yes, sir.
So both cutout part and hole will expand at same rate on increasing temperature. Khalid, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Next is volumetric. or cubicle expansion. Suppose we have a cuboid it may have some initial length, not initial breadth V naught, and height H naught. So on heating, each dimension will expand at same rate, so volume will increase at same rate from all sides. So it may acquire this configuration. So it will be final length, final breadth, and final height. Now, related to this expansion, we may define another term that is called gamma. So gamma in this part is called coefficient of volumetric expansion. So again, it will be equals to delta V divided by V naught times delta T. So its unit related to this expression will be Kelvin inverse or Celsius inverse. So we may define this gamma as the ratio of fractional change in volume to the change in temperature. So it is the ratio of fractional change in volume to the change in temperature. Again, we can say it simply defines at what rate volume of object will increase or decrease with change in temperature. So it defines the rate of change in volume with respect to change in temperature. Just write it down.
Done, sir.
Now, related to this expression, we may expand this as gamma equals to delta V by V naught times delta T. So on cross multiplication, delta V equals to gamma times V naught delta T. So V minus V naught equals to gamma times V naught delta T. Moving V naught to right side, V equals to V naught 1 plus gamma delta T. Similar expression as what we obtained for length, area. Next, related to this part, you'll be asked to find the relationship between alpha and gamma. So next is relation between alpha and gamma. As length equals to L naught, 1 plus alpha times delta T. Similarly, breadth B naught, 1 plus alpha delta T, and height H naught, 1 plus alpha delta T, since these all behaves as nothing but length. So according to linear expansion, we may write this. Now on multiplying, you get length into breadth into height, L naught, B naught, H naught, 1 plus alpha times delta T for first part, second and third. So LBH will be volume, L naught, B naught, H naught initial volume, and 1 plus alpha delta T to the power 3. So according to binomial expansion, we may further expand it as 1 plus 3 times alpha delta T equals to B. Hamza, is it clear?
Yes, sir.
Now just compare equation first and equation second. So what will be the value of gamma related to alpha? Just compare equation first and second.
Alpha is equals to gamma by 3.
Good. So from equation first and second, we can say gamma will be 3 times of alpha, or alpha equals to gamma by 3. Now, in general, we can say alpha is one-dimensional, so divided by 1. Beta is two-dimensional, divided by 2. And gamma is three-dimensional, divided by 3. So this will be a relation in between these three terms. Or you may take LCM of its denominator and multiply this whole part. You'll get 6 alpha, 3 beta equals to 2 gamma. Another relationship between these three terms. Khalid, any doubt?
No, sir.
Okay, just write it down. Hiba, done?
Yes, sir, done.
Okay. So we have just defined all three different expansion. Now on the basis of this, you will be asked some question. Let me give you. If coefficient of expansion of a radius of a sphere is 2 into 10 to the power minus 4 Kelvin inverse. Find change in temperature to get %3 change in volume. Try to solve. Iba, just tell me, what is this? Alpha, beta, or gamma?
Sir, sir, gamma.
Just read this statement. If coefficient of expansion in
Radius.
and radius will be 1-dimensional, 2-dimensional, or 3-dimensional.
Sir, 1.
So it will be alpha,
Alpha.
beta, gamma. Good. So alpha is given. Now we have percentage change in volume, you may convert percentage in terms of fraction and then put the formula and try to find the rest part. Khalid, any doubt? You may write percentage change in volume as delta V divided by V multiplied by 100 equals to 3%. So we have to somehow define delta V by V. So it will be 3 divided by 100. Now use this and this to find delta T. Try to solve. Gamma equals to delta V divided by V times delta T. So delta T will be delta V by V times gamma. Khalid, you got any answer? Okay. Delta T equals to delta V by V, we have 3 divided by 100. Gamma is 3 times of alpha, so it will be 3. Alpha is 2 into 10 to the power minus 4. So this part and this part will cancel out. 10 to the power 4 on moving to numerator, it will become 40 divided by 2 into 100. So 20 and 20 will cancel out. So 2 in 50 time will be this. So delta T will be equals to 50, either in terms of degree Celsius or in terms of Kelvin, it will remain same. Hamza, is it clear?
Yes, sir.
Salman, any doubt?
No, sir, no doubt.
Now, related to this volume, you will be asked to calculate effect on density. So next is density. As density equals to mass divided by volume. So let's say initial at low temperature, when volume is P0, density of object will be rho naught. Now, on increasing temperature, density equals to mass by volume. Initially, it is at temperature T0. Now, at some later temperature T, we have to calculate. So put the value of volume according to expansion. V1 plus gamma times delta T. Now this mass divided by volume is density. So we can write it as rho naught divided by 1 plus gamma delta T, having exponential 1 in denominator. So on moving to numerator, it will become rho equals to rho naught 1 plus gamma times delta T to the power minus 1. Using binomial expansion, this exponential will get multiplied with its coefficient, so it will become rho naught 1 minus gamma times delta T equals to rho. So from this expression, you will say on increasing temperature, volume will increase, so density will decrease. It means density decreases on increasing temperature. Khalid, is it clear?
Yes, sir.
Okay, just write it down. Iba, done?
Yes, sir. Done.
At 0 degrees Celsius, density of mercury is 13.6 gram per centimeter cube. Find its density at 100 degrees Celsius. If gamma is 2 into 10 to the power minus 4 Kelvin inverse. Try to solve using this above part. 13.6 is its initial density, that is rho naught. 2 in 10 to the power minus 4 is gamma. And change in temperature, we have 100 degrees Celsius. Just put all the values and simplify it. Hamza, you got any answer?
Yes, sir, but I'm not sure.
Okay, just send me. Khalid, just send me your answer. Hiba, just send me your answer. Just use the above formula. Rho equals to rho naught 1 minus gamma delta T. So we have rho naught as 13.6. 1 minus gamma is 2 into 10 to the power minus 4. Delta T is 100. So on solving, you'll get 13.6, 1 minus 2 into 10 to the power minus 2, or 13.6, 1 minus 0.02. Hamza, is it clear?
Yes, sir.
So 1 minus 0.02 will be 13.6 into 0.98. So on multiplying, I think you will get 13.32 something. So it will be 13.3 gram per centimeter cube. So this will be our final answer at this temperature change. Good, Khalid. Just write it down. Now this density or this volume will be applicable for all different objects, but there is exception in case of water for a particular temperature change, which is called Anamolus behavior. Of water. Let's say this is volume versus temperature, and this is density versus temperature. Let's say this is 4 degrees Celsius. In first part, for volume, from 0 degrees Celsius to 4 degrees Celsius. During this particular change, volume of object, that is at 0 degrees Celsius, it will be in form of ice. So on converting from 0 to 4, it will tend to increase its volume. So during this part, volume of object will increase, density will, just 1 minute. Volume of object will decrease and density will increase with increase in temperature. After it, 4 degrees Celsius and above, volume will increase with increase in temperature, and consequently density will decrease with increase in temperature. So if you plot graph of this particular variation from 0 degrees Celsius to 4 degrees Celsius, volume will decrease to the lowest at 4, and then it will increase like this. Similarly, for density, it will increase from 0 to 4 to get maximum density at 4, and then on increasing temperature, start decreasing like this. So this is exception only in case of water between 0 degrees Celsius to 4 degrees Celsius. It behaves just opposite of it. Why? Due to presence of hydrogen bonding in it, we can say. This behavior leads to the existence of or survival of aquatic life. Otherwise, it will be very difficult for them to survive underwater. You'll say why? Suppose this is surface of water in any ocean or water body. So on decreasing temperature of surrounding, formation of ice will start to form from the surface of water, since ice having low density as compared to water, so it will tend to float. So ice will form on the surface of water. On further, it will behave as insulating medium or act as insulating shield for the inner environment, so that the inner environment remain at 4 degrees Celsius and will have greater density as compared to ice, in which all aquatic life survives easily. Is it clear?
Yes,
Yes,
sir.
sir.
Otherwise, if rest of all material as it will behave on increasing temperature, density will decrease, and on decreasing temperature, density will increase. At 0 degrees Celsius, it will have maximum density. So ice will start to form from the lower part to the upper part, and then whole of water body gets frozen. So there will be no movement in aquatic life, hence they may die. Just draw this. Done, Hamza?
Yes, sir.
Now, the last part of this particular topic is expansion of liquid in a vessel. Expansion of liquid in vessel. Suppose a vessel in shape of this, or you may take some other shape as well. Now it is placed over burner. From it, heat is supplied to this particular system. And let's say liquid is filled up to this point. So you'll be asked, let's say this is level A. So what will happen to the level of liquid on initial heating? Will it increase, decrease, or remain same? There is no evaporation of liquid. We are calculating before that. Khalid, what will happen to the level of liquid? Will it increase or decrease?
Sir, on heating,
Yeah,
sir, I think it will increase.
level will increase. Okay. Hamza?
Sir, before evaporation, right?
No, before evaporation we are considering.
Sir, it will remain same.
So on heating, there will be no expansion of liquid.
It will expand, but after a like amount of time, it will expand.
Okay. So I'm just considering on giving heat to it so that it start expanding. So will the level of liquid increase or decrease?
Sir, it will increase.
Okay. Just think first on giving heat to this particular system, which will receive heat first, vessel or the liquid?
Vessel.
So which one will expand first, vessel or liquid?
Vessel.
So on expanding vessel, level of liquid in it increase or decrease? Good. So initially, since liquid is being or heat is being absorbed by vessel, so it expands first. So level of liquid decreases and then increases. Khalid, is it clear?
Yes, sir.
So you will see on heating, since vessel will receive heat first, so it will expand first, then level of liquid get decreased. On further heating, level of liquid will increase due to its own expansion. So we can conclude level of liquid first decreases due to expansion of vessel, then increases due to its own expansion. Hiba, is it clear? So let's say initially level of liquid is at this point On expansion of vessel, it may get reached to this point. On further expansion, due to its own part, let's say it reaches to this point. So from A to B will be expansion of vessel, and then from B to C will be expansion of liquid in real. So you will say B to C will be equals to A to B and A to C. B to C is real expansion of liquid. A to B is expansion of vessel. And A to C is apparent expansion or the false expansion which we will receive if you won't notice the expansion of vessel. Khalid, is it clear? Now, this particular liquid will have same real expansion in all of different vessels. So just remember, real expansion of liquid will be same in all vessels. Just write it down. Salman, any doubt?
No, sir, no doubt.
Sir,
Yes.
so will the vessel or whatever the utensil is, will it expand in all conditions?
Which part?
The vessel.
Yeah. Since it is composed of any metal, and metal will expand in all conditions if you
Okay,
increase its temperature.
okay, sir.
You all
Sir.
have done? Okay. Salman, done?